And you're dividing each of these by that thing. And I would write it out separately to avoid any sign errors or forgetting. And then you just divide. Now, it's the number on the outside of the square root that you're dividing, never the number inside. It's always just this thing on the outside, if it can. So this one works out to something like that.
Okay.
Any questions on this one? We could do
No,
another one
I
if
feel
you
like you
want.
just probably need another one.
Okay, do you want us to do another one?
Yes, please.
Okay. All right, let's go. So like two. So let's go 3 over 1 plus square root of 2 this time. So again, the idea is the conjugate is 1 minus the square root of 2. 1 minus the square root of 2, like that. Is that okay? That conjugate part?
Yes.
All right. So in the top, you distribute to both. So you get 3 minus 3 square root 2. On the bottom, though, you have to FOIL. So that's 1. And then the outer is minus square root of 2. The inner is positive square root of 2. And the last is minus the square root of 4. So this becomes, these cancel. Square root of 4 is 2. So it's 1 minus 2, which is negative 1. So it's 3 minus 3 square root 2 over negative 1. You do want to divide both by the negative 1. So 3 over negative 1 minus 3 square root 2 over negative 1. So you get negative 3 plus 3 square root 2 as your final answer on that one.
Okay.
Let's look at number 3. It says to divide. It really should say factor first. I think that's what the instructor is implying here. 6x squared minus 4x plus 1 over 3x plus 1. I think they're suggesting that there's something that will cancel. I don't think this is long division. I don't know if you've seen that yet in this course either. So in terms of factoring the numerator, there's a couple of ways to do it. Because they already give you one, though, I would recommend the guess and check approach, which is to say, okay, 3x plus 1, and you got to find the other binomial that foils back into this. So like whatever goes here foils back. And because it's 3x, the only way to get to 6x squared is to use 2x. No, you know what? This is not. This is definitely a long division problem. So I take that back. Have you done polynomial division?
Yes, I have.
Okay. All right. So that's what this one is. I was surprised, but that's okay. So you got to go back to like 4th grade and remember, like, what goes outside the house, what goes inside the house. And the thing on the bottom, the number on the bottom always goes outside the house. So you ask yourself, you say, what do I multiply 3x by to get 6x squared? And that's 2x. Now you put it above the x, not above the x squared. It's got to line up with the x's. And then you multiply each of these by 2x. So that's 6x squared plus 2x. And this is very important here. I prefer to call this change the signs. So if it's positive, it becomes negative. You are subtracting to start, but when you change the signs, then you add. Now it's always the case that the leading one cancels out. Sometimes this one cancels, but you just now add. Minus 4x plus minus 2x is minus 6x. Just like old time division, you bring the next one down like that. So then you do the same thing as you did before. You say, ask yourself, what do you multiply 3x by to get minus 6x? And the answer is minus 2. So minus 2 times 3x gives you the minus 6x. Minus 2 times the hypotenuse of 1 gives you the minus 2. And again, change the signs.
Right.
Change the signs. A lot of students only change one of them. Try to remember to change both. And then you should always see the first thing cancel out. It does. The last one though becomes 3. That is your remainder. This thing up here is the quotient. And then your divisor is here. You always write the answers in the following form. It's the quotient plus the remainder over the divisor. So for this problem, you would write the 2x minus 2, 2x minus 2 plus the remainder, which is 3, over the divisor, which is 3x plus 1.
Right.
There's infinitely many problems they could give you. Do you think it'll be like this one?
I honestly don't think you know what? I think I'm gonna send you, these ones are not as good. I don't know why I didn't send you all of these pages.
Okay.
I thought I did, but
So the next one, I have this other solve the system, and then I've got
Yeah.
another chapter 5 test A, got one of those.
yeah, I have this like practice, like it was like kind of a review and he said it's like very similar to the test and I thought it sent, maybe it just didn't send. Yeah, it definitely did not send.
Yep.
But-
I'll send, why don't you send there? That'll be more useful. It's worth taking an extra minute here to look
Yeah.
at that.
And well, we'll probably just do like one of each kind of problem because there's like 34. So we're definitely not going to finish that whole thing, but
Okay.
yeah, I just sent it over.
There it is. Okay. Do you want us to just go in order? There's certain ones you want. What would be most helpful?
Maybe just go in order and then if there's one that like we can skip, we can just skip it.
Okay. All right, so let me grab one here. All right, it says let f of x equal x squared. And here's the new function g of x. And they're asking about the transformation of the 1. So the first thing is here's the 1 right here. It's in this part of it. One thing you could do would be to graph this. The other is to just know that inside the function, it's a horizontal shift. Like you don't even have to say left or right, but you need to know that it's shift, not a stretch.
Right.
The two would be a vertical shift up. The 4 is a vertical stretch.
Okay,
Any
so
question?
because it's a one, it's not a because it's not a fraction, it's going to be a shift.
So the 1, I guess I'll just label each of these. The 1 is a horizontal
Okay.
shift. The 4 is a vertical stretch. And the 2 is a vertical shift.
Oh, okay. So. Okay. I got you.
Like I could see asking this question where instead of the 1, it asks for the 4 or the 2. Unless we think you're getting very similar questions. It could be any of the others, but that would be
Right.
my opinion on this.
Okay.
You could also just graph the x squared and then the x minus 1 squared and see what happens if you're really stuck, but you only want to graph the part that they're asking about. You don't have to graph all of it.
Oh, okay.
Okay, so next problem here, it says kind of the same question, but in reverse. It says like, here's absolute value of x. Absolute value of x is a v. great. And they're saying like, hey, this isn't the same parent function, but it's different. So like what's happened? Like, so maybe if you could do this in words, it would help. It'd be like, all right, it went left 2, and then it went down 1, and then it's a flip over the x-axis.
Right.
So if you look at the multiple choice, like you could graph all these, that's slow. You wouldn't want to do that unless you had plenty of time. The left 2 though will either get you down to A and C or B and D. Do you remember which one would be left 2? Is it x plus 2 or x minus 2?
It'd be x plus 2.
That's right. So it gets rid of those 2. The flip over the x-axis is the negative in front.
Right.
And then that gets you down to choice A.
Okay. Sounds good.
But it'd be very easy to, for example, have, get a different graph in a different place and then
Right.
Okay. Next one here. All right, compare each of the representations of the quadratics. They're saying there's 4 graphs. There's A, B, C, and D. They're asking, well, which one does not have the same minimum value? That means 3 of the 4 do have the same minimum value. You could, for example, graph all of these and see which ones are the same, which one's different. But they're basically asking about the vertex down here. There's a lot of work in this one. Not even sure how to suggest to proceed, but
we can just skip that one. We can go to
okay.
We can go to number, I think 6, that page.
Sure. These the way these questions are written, they're much more like standardized test questions that you might see, which if we ever do some practice on that, I'll give you some more strategies. But this one, again, not a solution. Those are always a little bit harder. Not a solution. So there's 3 of 4 that are solutions. Now solutions have to live inside this double shaded region down here.
Yeah.
Which I assume it's kind of hard to tell, but yeah, I guess so. That 1, 5, 1, -5, 2, -10, 0, negative. So actually I take that back. I guess the correct solution set is here. It's really hard to tell.
Right.
I think this is it. So they're saying, well, which one is for sure not in this region? And the other thing they're making more difficult is this dashed line. So this 0 minus 4, sorry, this 1 minus 4 is on a dashed line. There's this one is not. So 0 minus 4 is I guess I can color code some of these. So C is right there. That one's okay. 2 minus 10 is so far down that we presume that it's okay. And then 1 minus 5 we also presume is okay.
Right.
So there's a strategy when it says which of the following, you start from the bottom up. You never actually start top down.
Okay.
But that's not important for what we're doing for your test, but that's just a general strategy.
Okay.
Should we go to 7, or do you have another one that you would like us to look at?
We can go to 7.
Okay. 7, you could graph, but you do have to solve for y before you graph.
Yeah.
What you don't want to do is like try the solutions, because you've got a couple over here that doesn't work for. Do you remember how you might solve a system of equations by hand? Like what the 2 approaches are?
Yeah. So it'd be substitution or elimination.
Yes. Now, when the variables are opposite in sign, but the same value, you just add them up. You add vertically.
Right.
So in this case, when you add vertically, this is going to tell us something. 7x equals 63. And so x equals 9.
Mm-hmm.
And then you can use one equation or the other, excuse me, to find the other one here. So it probably is A. I mean, if this were SAT, we could just go with A, but we might as well just do a slight bit more work here to verify that it is A. So 9 plus 3y equals 57. 45 plus 3y equals 57. 3y equals 12, and then y does equal 4.
Yeah. Okay.
All right, let's go to look at the next question. So when you analyze a polynomial, you only care about the leading term. All the rest of this is not important. So if you're even going to graph it, you just don't even need to graph any of that. And the end behavior is what you care about. So the fact that it's x to the 5th, the fact that it's odd, you're supposed to say, oh, it's this when it's odd. It's starts low and ends high, but the negative flips that. So it switches the direction. Now there's 4 of these graphs to remember. That might be good for a note card. You could also, though, if you were to graph this, you would see something that looks like this. And that might be helpful. Do you want the 4 graphs, or do you think you will try to graph this on your calculator?
I think I'll probably try and do this on my calculator.
Okay. So sorry, I went the wrong direction. This one will look like this on your calculator.
Okay.
And so that's really interesting. Now x goes to negative infinity means this direction. As x goes to negative infinity, they're saying when you go to the left, what happens to the y value? Well, the y value goes to positive infinity. So that gets you down to A and D. So let me highlight that again, just so you can see it. As x goes to negative infinity, y, f of x goes to positive infinity. See how those are the same? And what that's referring to is when you go left, it's going up. Now I have to go the other direction. As you go to the right, as x goes to positive infinity, y now goes down to negative infinity. And so that is why this one is correct. So you can think of it as f of x being the y. This is the y. Hopefully that's clear. Sometimes the notation is more confusing than it needs to be.
Yeah, no, that makes sense. Okay.
Yeah, this type of question is very much a standardized test question. There is a better approach than what we're going to do, which is to just go through them 1, 2, and 3. But we can get to that if we do some SAT prep down the road, or ACT prep. So I don't even read these questions. Like I just go right to the thing here. The hose is 25 feet off the ground. They're basically saying like, and I think that's to start, which is right there. Is that 25 feet off the ground when it starts? Yeah, it kind of looks like it's 25 feet off the ground. Is the height, so we think that's true. We think that's good. The height is a maximum of 33 feet. Is that kind of the maximum of the height? Yeah, that also seems true. The water hits the ground 40 feet from the truck. So this is time. It's not distance. Sometimes when it's X, you don't think, oh, I'm sorry, it is horizontal distance. That's odd. Usually it's always time. Okay, so this is horizontal distance. So does it hit the ground 40 feet from the truck? Well, there's 40 feet. Looks like it hits beyond that at 50. So that one is probably not true. And then you would match up your correct answers to the ones that are available,
Yeah,
rather than trying to work off this backwards. So it's always better if you go through it and decide what's true or not, and then match your answer to the one that's there.
yeah.
All right. Next problem I see is 17. Oh, I'm sorry, I missed a page. Should we go to 10?
Yes.
Okay. This one, I would tell you to graph on your calculator, because the graph will match it pretty closely. What they really want you to do is, without a calculator, determine the zero and the multiplicity. So for example, x minus 2, this x minus 2, it has a 0 at 2, but it has a multiplicity of 1 because there's an exponent of 1 there. And what that means in words is that it crosses. So you're looking for something that crosses at 2. So it could be the A, it could be, actually it could be all of them, so that doesn't help. Sometimes it doesn't help. X squared has a 0 at 0. Like when x squared is 0, it's 0, but it's got a multiplicity of 2. That means it touches or bounces. And that helps to get it down to either A or D, because if you notice, they both bounce there at 0.
Right.
But like I said, if you were to graph this, you wouldn't immediately know it's, sorry, my screen froze up. Of course, it's A. You would just see that. So I don't know why I would tell you anything to do but to graph this.
Right.
There are other ways to figure out what's going on, but is that okay, or do you want more explanation on that?
Yeah, no, that's good.
Okay.
All right.
Next one here.
Yeah, number 11.
All right, so this one asks about the average rate of change. It says the temperature on a given day was this, and then this. Average rate of change, AROC, kind of a big deal in these courses. It just means slope. It just means y2 minus y1, x2 minus x1. Probably the hardest thing is to figure out, well, which, you even wrote that here, or you got that down in your notes. That's, and sorry, this would definitely be something to write down, more so that AROC is slope. That would be very important to put down. But like, well, which is on the top, which is the bottom? They tell you what's on the top. They say temperature, whatever they're asking for, that goes on the top. So that's, and it's the later one minus the newer one. So it's 90 minus, sorry, 103, not the, and then from 11 p.m. to 5 p.m. So that's minus 13 over 6. And that's why you gotta be careful. See how both answers are here, whether you get your sign right. Think of it as I don't know, new minus old. That could be one way to think of it.
Yeah. That is a good way to think of it.
All right. Number 12, just grab the graph of this. So it's really all that's needed. You just connect the dots when you see stuff like this, and you try to envision like what is happening, which I think you can see that this is U-shaped,
Right.
but it's going down. That just means it's a quadratic.
And it's opening downwards.
Yes. Give me just a moment here, please.
Okay.
All right, I'm back. I apologize for that. And so like linear, I see some other options here. I mean, linear, obviously, like there's up is positive slope. This is negative.
Yeah.
I mean, I don't want to get into all the nuances of this. Like this one has like a clear curve to it.
Mm-hmm.
Positive one might have just a general direction, and same with the negative. It might just have a general direction. But you could try connecting the points. Is one possibility. But if they're staggered, you know, you might be doing something like this, and that's not the idea. It's a so I anyway.
Yeah.
These questions seem more, they seem different than what we've been doing, meaning like either like these are like representative of a common final exam, or maybe your teacher's just reusing something, because the questions you've been giving have been more like free response and more of just work these out. These are more, like I said, standardized test prep type questions.
Right.
Okay. Factor the polynomial here. So what you look at is what's the same in all three, and x is the same in all three. So that's 3x squared plus x minus 4. Again, you divide out what is common to get the new terms. Now, because it's multiple choice, I think you can see that like this boils into something. Maybe hopefully you see that, like,
Yeah.
like, and there's got to be an x on the outside. So it's either A or B.
Right.
And what I would tell you to do is to FOIL like 3x minus 1 times x plus 4. FOIL that and see if it gets you back to this one.
Mm-hmm.
And if that one doesn't work, then it must be the other one. And we're doing this because it's multiple choice. We're doing it because that's the format of this that we think.
Right.
So this is 3x squared plus 12x minus x minus 4, 3x squared plus 11x minus 4. So that one did not work, which means that it must be A.
Yep.
And that's that. I mean, that's the extent of that. Now, it really is helped out by factoring on an x first, but that's there's a few things you can do in these tests to save yourself some time when you do that.
Right. Okay.
Moving on. So find all the zeros. That means to set the function equal to 0. You could also graph this thing and see where it crosses or touches.
Mm-hmm.
This one, what does it do? It goes, I don't know, it crosses, it looks, I think it would look something like that. But we'll see that also by factoring, but you could just straight graph this one. So when you factor, greatest common factor is an x, like this.
Mm-hmm.
And then the greatest common factor, I'm sorry, the next thing here is its difference of squares. And this becomes x minus 4, x plus 4. Difference of squares, this might be good to have down. A minus b, a plus b. So in your problem, it's really x squared minus 4 squared. That's how they got the 16, the 4 squared. And that's why your a is really x and your b is really 4, x minus 4, x plus 4, like that.
Yeah. Got you.
All right, so number 15, just a moment. All right, so 15 is quadratic formula. Whenever you see the answers in this format with the plus or minus and the square root, that's quadratic formula. It's like a giveaway. Again, like there's other options to this. Like you could graph this one right here. You could find the zeros and like figure out which one of them matches up to this. I mean, that's not the right way to do it, but when it's multiple choice, you have a few more tools available to you. I will go through it with the quadratic formula here. So you identify the coefficients here. It's ax squared plus bx plus c. So a is the number in front of x squared, which is 1. B is the number in front of x, which is 3, and c is the other number. And then you do have to know this. This is your quadratic formula. This would be worth writing down. B squared minus
Yeah.
4ac all over 2a if you don't have that down.
Mhm.
And then you're just plugging in the numbers
Right.
for this. So it's minus 3 plus or minus the square root of 3 squared minus 4 times 1 times 1 all over 2 times 1. And when I look at the answers, I notice the part inside the root is different on 2 of them. So that's a helpful way to get it down. This becomes 9 minus 4, which is 5. You gotta be careful with your signs. So it's minus 3 plus or minus the square root of 5 over 2. And you could see if you go back to the answers that that gets you down to like A and C. And then because it's minus 3, it's
Right.
that one.
Okay.
They do ask questions on the SAT, ACC that are just quadratic formula. They're just solve it using quadratic formula. Okay, a complex number has a real part equal to 7 and an imaginary part equal to 3. The only answer that has those is B. B is the answer. Now,
That's
like you are supposed to know that A is the real and B is the imaginary, but I mean, they ought to at least throw in a 3 plus 7i in here to confuse you, but they didn't.
right.
But that's so this would be something else to maybe throw on your note card.
Okay.
Okay, so 17 is actually, this is a really good question. You have to substitute in for x and y. They give you x, they give you y, and then they give you z. And so you have to take x and y, multiply, and then you have to add the other one here. I think this is a good question. You got to be able to FOIL and then combine like terms. So foiling again, first outer, inner, last. 9, 3 times 3 is 9. 3 times minus 2 is minus 6i. 2i times 3 is positive 6i. 2i times minus 2i is minus 4i squared. Plus 1 minus I. Main thing here is I squared is negative 1. Super important to have that down. I've seen students try to combine these things. They don't combine. The I squared is different. Minus 6i plus 6i, they do cancel. So you're down to 9 minus 4i squared plus 1 minus I. Eventually, you got to plug in that I squared is minus 1. You are essentially just changing the sign of it, but I would write it as minus 4 times minus 1 and then get it down to 9 plus 4.
Okay.
And then from here, just combining like terms, 13 and 1 is 14, 14 minus I, and that is your final answer. Now, some calculators have the capability of just doing this. I have no idea. I wouldn't count on that.
Yeah, no, I don't think mine can do that.
18 is really similar to, last one says this, final solutions of x squared minus 6x plus 10. You might think it factors, but it does not. There's not two numbers that multiply to 10 but add up to 6, negative 6. 1 and 10, 2 and 5, they don't work. So when you can't factor, your other options are completing the square, which no one likes, or quadratic formula. So given that it's quadratic formula, you can eliminate some of the answers. I don't think you want to guess on a final, but like on the ACT, SAT, guessing is totally okay, especially if you can get it down to 2. But like those are not going to be it. So we gotta then use the quadratic formula again. Okay, so it's opposite of b, 6 plus or minus the square root of b squared. Now it's important to put those negatives in parentheses, minus 4 times 1 times 10, all over 2 times 1. So that's 36 minus 40. And here, so that becomes the square root of negative 4. 6 plus or minus square root of negative 4 is 2. And that's getting closer. So that's 2i inside here. The square root of negative 4 is 2i. The square root of like negative 9 is 3i. It's whatever that number is with the I appended to it. So 6 plus or minus 2i over 2. And you have to divide both. So it's 6 over 2, 2i over 2. And that gets you down to 3 plus or minus I.
Right. Okay.
Now, like full disclosure, you probably could have figured out the answer was C because of this first part.
Yeah.
And I'm okay with you doing that. Like I would tell you to do that on these standardized test things, but I'm just not sure here.
Yeah.
I mean, if these are exactly the same, not only do you know the answer, you know how to do it, but they're a little bit different. Maybe you can look for something like that. All right, now we're getting short on time here. If there's some you want us to do, please tell me. This
Yeah,
one could be longer than necessary.
Yeah, we can skip that. I'm looking through all the pages to see if there's any that I should go over. Maybe 22.
Okay. Okay, so 22, right off the bat, there's this technique in standardized tests, which is like, what's the same and what's different in the answers? And the what's same and what's different here, you notice that the front numbers are all different. This 2 needs to match. So that means that there's a couple you just get rid of. It's not A and it's not C.
Right.
So that's an important thing. The next thing is to rewrite this polynomial here with the missing ones. You're like, what's missing? 0x squared. The reason it's missing is in descending order is the way these have to be listed. So your coefficients are 1, 0, -1, 1. And those are the coefficients that you're looking for here.
Right.
So your answer is D without even answering it. I would have added a second question, which is to figure out what the actual answer is when you do the synthetic division, but you don't need that. You just need to set this up properly.
Yeah.
And you set it up properly by knowing that it's 2, okay, which is the number that goes over here. If it were -2, then it would be this other one, and then getting this. What else can we do?
Let me see. Number 24.
Okay. Where'd it go? No, there it is. Nope. Okay. Which statements about rational exponents is/are true? So to answer like the first one, I always go back to the square root of x. There's really a 1 here and a 2 here, which means it's x to the 1/2. So that number that number there inside the root goes in the top. So does that match? Yeah, that matches. So one is true. Which means that the second one is not true. But this is what I was trying to show you here on the right. This is like one of those things I write down or now I remember so that I don't ever put the wrong order in that.
Right.
Okay. Now the last one here, when you have an exponent to an exponent, you multiply. So it's a times b over a, which equals 1, but it's x to that, so it's x to the 1. So this does not equal 1, so it's not true. So it is one only.
Okay.
Really a good question. Just students, I wouldn't like this as a student. It's really a good question because there's a lot there to piece together.
And then maybe 29.
Okay.
I think is the one I was looking at.
So 29, we could do like the traditional way, how you would solve by hand, but we're not going to. We're going to use the answers. You don't have to show work on this, I hope. That would be something we haven't, but like I would just try the answers. Like,
right.
but they have to work. Now there's this well, I don't want to get into that. So let's just try 7. X equals 7. See if it works. So is 7 plus 1 equal to the square root of 7 times 7 plus 15? Is 8 equal to 49 plus 15 square root of 64 equals 8? So yes, 7 works. Yay. Okay. But then we got to figure out, well, does -2 work?
Right.
So -2 plus 1, does that equal square root of 7 times -2 plus 15? What is -2 plus 1? I am asking you. This is important that you get this right.
It's -1.
-1, yeah. Now the square root can never be negative. Can never be negative. This ends up being the square root of 1, which is 1.
Yeah.
It's not -1. So this is false.
Right.
So we know that -2 does not work, which means that 7 does work.
So it has to be C.
It has to be C, yeah.
Okay.
You get a problem like this or one really similar to this, just try the answers.
Okay.
For sure. That's how we do it that's how I tell people in the SAT. There's actually a table approach and there's some other things we can do to make this really even more efficient, but yeah. What else? We got probably time for at least one more if you want.
Yeah. Let's see. So for 30, is that just saying, so if it says if f of x is equals this and then g of x equals this, and then it's saying find f plus g of x, do you just add both of those equations?
Yes.
So you just combine like terms.
That's right. But they're not always matching. So there's a 2x cubed and a 4x squared plus a 3x and then -8. Like they've got to be exactly the same.
Yeah.
To combine.
Okay.
Just to comment on the last problem there, 33. 0.731 repeating means 0.731, 731, 731. So if you put them on your calculator, please be sure to find the one that actually does repeat. Which, I mean, the answer is A, but the important thing is that you know what repeats and what doesn't.
Okay.
Anything else here? I'm happy to answer another question if you really feel like there's one you're not sure about.
Let me see real quick. Maybe 28.
Okay, this will have to be our last one. Is
Yeah.
this okay?
Yeah,
That's one you want to do. All right. Let me now find it. Okay. Boy, put the following steps in order. So they're moving to this on some of the online platforms to actually do it where you have to work through the steps. I think that's one of the hardest thing for a student to do. But the following steps in order to solve the quadratic. Okay. So they're basically saying, like, imagine you're told to solve this right here, like excluding all the information. What would you do? Well, you would subtract 6 from both sides to start.
Okay.
So that's one. We'll just say 1 there, or sometimes it's better just actually write out that's 1. Then you factor. So that's 2. You set each factor equal to 0. That's 3. And then you solve each new equation, which is 4. So now it's like to get the mapping right. So you want the two Roman numeral 2, then the 3, then the 4, and the 1. Yeah, that's almost harder. I could almost just ask you that, and that'd be really hard to map these things.
Yeah.
Then you get to college. I mean, they do all kinds of weird things. They switch true and false from A to B. They say, you know, A and B, or you know, they do things that aren't necessary. But anyway, yeah, that's it for tonight. Thanks for scheduling. Thanks for letting me reschedule with you. I really appreciate it. I just want to assure you, if you ever can't do something, I'm okay. I would have modified schedule. But thank you for letting me help you all semester, and hope you have a great holiday with your family and friends. And I'll be available next year.
Yes,
To
thank
help
you
you.
so much. I'll definitely be scheduling for next year once we start
Awesome.
our new stuff.
Yeah, awesome. Hope you do well, and I'll see you next time.
Thank you.
Have a great
Bye.
night. Bye now.